Good morning, everyone, or good afternoon, depending upon where you're tuning in from today. Velodyne Lidar Live is back for our second season, and we do have a packed first episode for you today. We are kicking it off with one of our new Tech Talk episodes, and these webinars will feature technical deep dives around specific Velodyne products or around full stack solutions that feature one or more of our sensors. So this morning, Sherwin, Cabatic, and Chris Thompson are going to be focused on our Velarray M1600 sensor and how it can be combined with our Vella Development Kit, which is our software solution. And I'm going to pass things over to Sherwin and Chris in just a minute so they can get started. But first, a bit of housekeeping before we get going. We'll be opening it up to audience Q&A towards the end of the episode. So be sure to use the Q&A button at the bottom of your screen, and you can ask questions anytime during the episode. As always, this webinar is being recorded and will be available to watch on Velodyne Lidar's YouTube channel. So now I'm going to pass things right over to Chris and Sherwin. Hi, guys.
Great. Thanks, Pam. Slide set, I think. So Mary, maybe the first slide. Great. Hi, my name is Sherwin Cabatic. I'm the segment lead for Robotics and Industrial here at Velodyne. Thank you for joining us today. Technology is moving fast, and there are many challenges to automation in robotics. As our customers strive to solve increasingly complex problems, they can look to Velodyne to be their trusted partner. Our vision is science in the service of safety, and our mission is creating smart technology for a world in motion. With our latest sensor, the M1600, and our Vella Development Kit, you can depend on Velodyne to solve your sensing problems, accelerate time to market, and in the end, save precious development dollars. So in the next few slides, what we'll do is review some of the typical problems that our customers are facing, and then we can go into some of the solutions that Velodyne can offer. Next slide, please. In this example, you can see a sidewalk delivery robot. This is a very typical application for our customers, and there are several risks to mitigate here. First and foremost, you need to know where you're going. You need to know how to get to the destination and deliver the payload in time, whether it's a cup of coffee, a pearl tea drink run, groceries, or office supplies. That's the primary purpose of the robot. In order to achieve this goal, you must be able to avoid obstacles, both fixed and moving. You need to find a safe path on the sidewalk. As you can see, there are people moving around, there are fast cars moving on the roadway, and most importantly, don't hit anything or anyone. Being outdoors, the robot and the sensor needs to deal with wide-ranging environmental conditions. Rain or shine, from winters in Ottawa to summers in Tokyo, it must operate well, efficiently, and safely. Lastly, this robot is small and compact, and it runs on batteries. The sensor must also be small, embeddable within the robot architecture, and not draw the power of the sun to operate. In other words, you must have low power consumption. Next slide, please. In this next example, there are a different set of challenges. The tasks remain the same, however. Deliver the payload to the right place efficiently and safely. The environment is different, but equally challenging. The robot is now working indoors with shelves stacked with inventory. It must stay on a selected path, but also account for any machines, inventory, or materials in its way. The field of view must be sufficient to account for all the hazards and all the directional guidance that it needs. In this one example, you see there's only one robot, but we have customers with fleets of these robots in the same warehouse. Collision avoidance and safety are paramount. Next example, please. This is the last one, And as you can see, we're on a factory floor, but the conditions are slightly different. Again, the task is the same: deliver the payload efficiently and safely to its destination. In this case, one, you can see the lighting isn't quite as good. So the camera here doesn't have as much sight as to what's in the way or the different obstacles. People are sharing the same space. So you have people working, moving, and walking all in the same space. The robot must take these into account and move safely through this environment. This is quite a challenge. Next slide, please. As you have seen from the previous examples, there's really a multitude of challenges for automation and robotics. Velodyne is your innovator in LiDAR, and we have years of experience working with customers on solutions. With our suite of sensors, we have a solution for multiple applications. The M1600 is just one of the latest in the family of the Velarray family for us. Combined with our VDK software, the M1600 will get you up and running and reducing development time in dollars. As illustrated here, we have a full suite of sensors from our high-performance rotational alpha prime to our compact and lightweight puck family, and then to our Velarray family of sensors. Velodyne has the sensors that you need. Next slide. The M1600 is ideal for robotics. With range from very close to very far, a wide field of view, the M1600 can provide the LiDAR vision you need. Our innovative micro LiDAR array, industrial grade durability, and ASIL B certification will meet your automation needs. Robots can really rejoice. The M1600 is designed specifically for you. 24/7 reliability, application tailored specs, small embeddable form factor. You can use it as a centerpiece of your sensor suite. The M1600 enables leading edge performance and exemplifies our mission, creating smart technology for a world in motion. Next slide. I hate to be cliche, but I will. Wait, there's more. Velodyne goes beyond sensors. Chris will talk about our VDK Vella Development Kit and show you how we can provide even more value with our software. Take it away, Chris.
Thanks, Sherwin. Thanks everybody for joining us today. My name is Chris Thompson. I'm the senior manager for the Vella software product team. I'm excited to talk to you all today about the Vella Development Kit, the solutions it provides. Next slide, please. So first, I kind of want to give an overview of the Vella Development Kit, what's involved. So the Vella Development Kit, or VDK as we often call it, provides rapid integration of Velodyne sensors into perception solutions. And as Sherwin mentioned, this saves a lot of development time and engineering effort. I think you'll see in this presentation that through this solution that we provide to you, you can really get your solution up off the ground and running as quickly as possible. I want to note that there are two VDK packages. We have a current package that's available now is the VDK Outdoor, and coming soon in Q2 is VDK Indoor. There's some slight differences between the two, but the VDK Outdoor has been available since the middle of 2021, and we've been updating it, providing new features and new capabilities. And the Indoor will be coming, as I said, very soon. As far as the supported sensors, the current release that we have out and available supports the Velarray H800 and the M1600. And the upcoming release will support Puck, Ultra Puck, and Alpha Prime as well. Another thing I want to mention about this is that the VDK is a full hardware and software solution. We provide the software, but we also provide the hardware to run it. So you don't have to worry about, the hardware that you need to actually run the software. We have fully tested and developed on these platforms, so you can have good confidence in using them. The first platform we offer is the high-performance Linux laptop. It's got an NVIDIA GPU that we take full advantage of. And the other option is an NVIDIA Jetson Xavier AGX. It's a small form factor embedded solution with an ARM processor. And of course, it has NVIDIA GPU capabilities as well. And as I mentioned about the updates, we do provide quarterly updates for VDK. So when you have a license for VDK, you can get updates as they come out and add and upgrade your system. And with that, you'll get improvements to algorithms. You'll get improvements to our machine learning models and things like that. And you get any new features that come along with VDK whenever there's an upgrade. The other thing I want to do on this slide is quickly go over the feature set. We'll go into more depth in these and show some examples later. But to go through them really quickly, first we have object detection and classification, where we detect and track objects and classify them according to what kind of object they are. We have 3D obstacle and free space detection. This is often referred to as an occupancy grid, which helps with path planning and avoiding obstacles for a robot. We have LiDAR odometry, also referred to as LiDAR SLAM, where we use the LiDAR itself to determine the vehicle's location and orientation. We have LiDAR to vehicle calibration. I'll talk about all these things in more detail later. In this one, I'll go in a lot more detail. But this is ability to determine the relationship between the position of the LiDAR and the vehicle itself, which helps your robot or vehicle make the decisions it needs to make. Another feature is scene segmentation, where we provide information about all the different areas in the scene. This is a method used to provide drivable areas when you have a robot moving around. And the last thing I want to mention is that the VDK is fully integrated with the robot operating system. For those folks who aren't familiar with the robot operating system, it's a software framework that provides modules for sensors and algorithms and things like that. And it's a well-known and well-used. It's been around for a while now. Lots of folks are using it, but it's a system where you can easily take your system, your robotic system, and drop on different features and functionality such as VDK, and integrate it within your system to work with other features and aspects of your robot or vehicle. Currently, we support ROS 1, and coming soon is ROS 2, which is the next generation of the robot operating system. Next slide, please. So just to go in a little more detail on the software features, we'll go again with a little even deeper dive. I just kind of want to talk about some general ideas here. So on the object list, in each of these, we have a little bit of a preview of what's going on. For the object list, we have objects that are categorized and demarcated with 3D bounding boxes. So you get the category, the object velocity, as well as the size, position, and orientation of the object. And this is all fed back into the system. So you'll see here, it's shown on a graphical interface. But the other thing that we do with VDK is we provide all this information as output via ROS, via the robot operating system, so that if you have a system that's doing decision making, it can use output from VDK in order to make those decisions for things like path planning and things like that. And that applies to all of the VDK capabilities. All of them have these ROS outputs so that you can integrate it into a larger system. For obstacle and free space detection, you can kind of see here that there are essentially the areas that are not safe to drive are marked, and then this helps your system do some path planning to know where the vehicle can safely move. Scene segmentation provides some similar capability where it has drivable areas and non-drivable areas. There are several categories involved. We'll get more into detail with those later. And then extrinsic calibration, which is another term for the LiDAR to vehicle calibration. That's a cloud-based service, and we'll again go into more detail on this later, where we take data and we help you determine in your system where the LiDAR is in relation to the rest of the system, so that your system can make the best decisions as far as path planning, obstacle avoidance, and things like that. Next slide, please. So the next thing I wanted to talk about is the VDK system integration. This is a pretty simple drawing, and I think it reflects the simplicity of getting VDK set up. So as we mentioned before, you'll have a LiDAR, and then we'll give you the compute hardware that you need to run VDK, whether it's a laptop or an AGX. So the sequence of getting going with all this is pulling everything out of the box. You plug in your LiDAR, you turn your LiDAR on, you power on your compute hardware, the laptop or the AGX. You might need to do some network configuration if you haven't started up before, and we actually provide a script to help you do that. So it finds the LiDAR, gets your compute hardware configured to listen to the LiDAR and receive all the data coming from it. And then you're ready to run the VDK. This is a command line application. So you can start up, you say VDK run, and you might provide object list or some other, one of the other segmentation or, one of the other applications. And by default, it starts receiving data from the LiDAR, and then the graphical user interface comes up and starts showing you the results. So that previous slide had some kind of previews of what this looks like, and we'll go into it and show some examples here in the upcoming slides. But you get to see all the things marked. You see bounding boxes, you see the different areas in segmentation, that sort of a thing. And of course, as mentioned before, the other thing that's happening here is all this application output from the VDK is provided via ROS. So if you have any downstream application that needs to do robotic decision making, that sort of a thing, it can receive this data and use it in your solution. Another thing I want to mention here is that this is kind of the simplest setup. You can actually enable further capabilities with VDK if you provide odometry from your vehicle. And by odometry, I mean the vehicle's location, the vehicle's orientation, and that sort of a thing, and speed. And so when that is provided into the system, then the VDK can use it to allow, and we'll go into this a little more later, but it enables things like motion compensation on the LiDAR, and it also enables more robust and better output from our algorithms. So you get another bump in performance when you do that. Next slide, please. So here's our first example. We've got a couple of pedestrians walking around. This is indoor object list with VDK, and you can see here there's a little video down on the bottom there. You can see a couple of folks walking around there, and the VDK indoor identifies pedestrians. It does not identify other objects yet, but those are coming soon. We'll have additional classifications in the VDK, and you'll see in outdoor there are a lot more that are already supported. But you can see as this is going on, the tracking, the bounding boxes are tracking the folks walking around, and as the folks turn around and they sit down, the orientation of the bounding box reflects the direction that the person is moving in, and you really get a good idea of where the person is moving and how they're moving, and you can start to imagine how that is useful when you're doing robotics and trying to predict, make decision making as far as your path planning and that sort of thing. Next slide, please. So here we are outdoor, and you can see here there's several other things already getting detected in this video. I'll go down the list real quick. The VDK can identify large vehicles, small vehicles, pedestrians, bicycles, motorcycles, buses, trailers, and then generic objects like traffic cones and that sort of thing. So as we're driving down the street here, you can see there's all kinds of vehicles being detected on the side streets, the cross streets and that sort of a thing. We have large vehicles and small vehicles. There's some pedestrians. There's some cones in the median right there going by that are detected in the light blue. So there's all kinds of things happening here that this LiDAR is picking up in the field of view of the LiDAR in front of it. I think you can start to imagine how this is useful with an indoor-outdoor situation. There's a bus that's going by on the left as far as being able to predict where things are going. The one thing to note here is there are velocities on these objects, so you know the direction that they're going in and you know how fast they're going, so you can predict collision and that sort of a thing. And here's some pedestrians going by. So you can really start to see how, again, out of the box, you plug in your LiDAR, you start this thing up, you can take it outside, and you can see all these things starting to be immediately detected and tracked. Next slide, please. So being a LiDAR company, we always have to show how great this works at night. You can see on the right, there's a camera image. There are a few things being detected in that camera image, but by and large, you can't really see what's going on, even with the human eye, that you have limitations that this LiDAR does not have. You can see it detecting vehicles far off in the distance consistently. There's going to be a vehicle coming up on the left side here. Just a portion of the vehicle is visible, and we're already detecting it as a vehicle. And again, providing information into your system so that you can make decisions for your robot or vehicle, what have you. I just have to show this because it's such a great feature of LiDAR that you don't get with other sensors so much. Okay, next we'll talk about LiDAR odometry. So this is a feature that provides the vehicle's relative position and orientation. You can see in this video, we're showing the path that the robot has followed. So you can see as the vehicle turns, as it corrects its path and it's kind of, going back and forth a little bit here. It's all tracked. And what this means is that you're providing all this information in real time into your system, so that, again, it helps with decision making for your robot as far as where can it turn, or where should it turn, how fast is it turning, that sort of thing. But the thing to note here is that there is no inertial measurement unit involved. This is done purely with LiDAR. There's no IMU or no GPS involved. So what we're doing is we're taking the LiDAR data over time and we watch how the scene has changed, and then you can track, well, the vehicle must have moved forward so many meters or turned so many degrees based purely on LiDAR. So this will help in situations where you might not have the full sensor suite of a more expensive, an expansive robot. You can do all this stuff just with LiDAR. And again, it's another thing out of the box. You can turn this on, and you can start getting odometry data, start working on your solution using the LiDAR. Next slide, please. So next up, we have obstacle and free space detection. So what you're seeing here is, what we often call an occupancy grid, where all the blocks are essentially areas where there is an obstacle, right? The other thing you see here is the ground plane. These things are, again, like all these features, these are output and available to the rest of your system. But you can see there's in a darker blue, there's a ground plane of kind of where the vehicle can move, and then there are the obstacles where you largely don't want to drive. You want to avoid those obstacles. And so you can really see, and you can start to think about, again, you get this out of the box and can integrate it in your system, and you start to have the capability to say, well, here are the areas my robot should drive, here are the areas my robot shouldn't drive. You can see at the beginning of the video, there's some people walking by. It's working on dynamic obstacles and active obstacles. And I don't know if you can see it, but up in the distance, there's actually a person walking ahead that is also showing up as an obstacle. And this is all working in real time on your robot. It's very useful in order to get your robot up and running. And again, you can do it quickly because it's working out of the box. Next slide, please. So here we have scene segmentation. This is a pretty amazing feature where the scene is broken down into various areas. Okay, we have a drivable surface, which is this nice smooth road. You have non-drivable surface, which might also be a smooth area like a sidewalk, but obviously you don't want your vehicle to drive there. So we have our system set up to detect what these different areas are and to help your system make better decisions as far as where it can go and where it should not go. Other things to note here are that there are the notion of movable objects and fixed obstacles, right? So a movable obstacle is something like a vehicle. You can see them at the beginning of here we go, over on the left, you can see some pink objects. Those are parked cars on the side of the road, which is important to know for your robot that, one of those things might start moving. So it's important to, when you're making your calculations about probabilities of things moving or not moving or where you can go, that there are movable objects there. And then you also notice on the side of the road, there are things like stop signs and such that are clearly marked as, fixed obstacles. If there were a median or something like that, or grassy area, that would show up as terrain, which again is a place where you don't want to drive, but you have further information on that. I think you can see a little bit over on the right here, some terrain where you don't want to drive, but this gives you a lot of information, a lot of feedback. Again, it's all available via ROS, and you can feed it back into your system. And again, another thing out of the box, this starts working, and you can start working on your solution because you have a lot of information about the environment, all these things that a robot would need to know in order to, properly navigate and safely navigate a situation. I will note that segmentation is not currently available indoor, it's only on outdoor, but in the future release, we will have segmentation available indoor also. But you can see here in outdoor, it's super useful, provides a whole lot of information on your environment, which is crucial for your vehicle to be able to make the decisions it needs to make. Next slide, please. So the next thing I want to talk about is extrinsic calibration, also known as LiDAR to vehicle calibration. So the idea here, in this instance, we're talking about the relationship between the LiDAR and the vehicle itself, and then the translation between the two. So when you have a LiDAR, it's typically mounted on a roof or wherever it's mounted, and it's sending out signal, it's getting returns back. All those returns are relative to the LiDAR itself. The LiDAR is the is the point of reference in that situation. Same thing with our VDK. It's making all these decisions. It detects, or not making decisions, but it's detecting objects, ahead of the lidar itself. So if it sees an object at 8 meters, it means it's that far from the lidar, and that's kind of as much as the lidar or the VDK can know. So there's a notion of like, how does this relate to the vehicle? The vehicle has a different set of parameters that it needs to know. For example, if the lidar's on the roof, there's a whole bunch of car in front of it, there's a bumper and all those kind of things. Well, the vehicle has the knowledge of what all that is. So you need a way to be able to translate between what the lidar is seeing to the frame of reference of the vehicle so that you can make smart decisions for the vehicle itself. So this is where our extrinsic calibration comes in. So it provides us information. And the way we do this is there's a feature in the VDK. There's a setting where you run and you collect data. You collect lidar data and you collect odometry data about your vehicle. Again, that's orientation and velocity and position. You feed all this data in. We collect the data. You drive in a certain pattern. We collect the data. Then you upload that data. And we process all that in the cloud. We then generate from that a YAML file, a text file that describes this system, and it tells you what the relationship is between that lidar and the vehicle. So now your system has the information it needs to know to apply that. And for folks who have been doing robotics for a while, this can be one of the biggest troubles and hassles. You spend a lot of time making sure your calibration is correct, right? You have to measure and record this calibration, and then if somebody takes the system apart, puts it back together, you need to know if something's changed. You need to know if you decide to move the lidar to somewhere another place on the vehicle, it means you have to do the same process again. So you can really spend a lot of time on this, and even kind of designing how it would work takes a while. So we provide, again, out of the box, this capability. So once you have this file, there's a couple things you can do with it, which really open up more possibilities. As we were mentioning before, if you're providing odometry along with the lidar data, it unlocks things like motion correction. The third thing you need in that situation is the translation between the vehicle itself and the lidar, so that you can really pull all this information together. And so this information helps you do things like lidar motion correction, which, as I mentioned before, enables better perception performance. You get better results out of the VDK, and we provide you all the tools to get you to that point where you're getting the best results you can. The other thing where the other area where this is useful is as the VDK outputs are coming out, they are relative to the lidar itself. And now you have the information you need to know that, okay, you detected an object 8 meters in front of the lidar. There's about 2 meters of hood and windshield in front of the lidar itself. So your vehicle now knows, well, you said it was at 8 meters. When I do the translation, that means it's 6 meters in front of my bumper. And I know that I'm that much closer, and I can make a much more informed decision on what my robot should do, or what my vehicle should do about that object that's in front of the vehicle. So you can really see that, for anybody who's been doing robotics, or if you're starting out with robotics, this is one of your biggest concerns, is how do you relate the lidar itself to the vehicle? And we provide you a path to get to the point where you can know the relationship between the lidar and the vehicle. And it's just a matter of collecting some data, sending it our way. We give you the results back. And this is all included in VDK. That's all I wanted to cover as far as features. I thank you all for listening. I'll hand things back over to Sherwin now. Thank you very much.
Very cool, Chris. Thank you very much. As we discussed with all of you today, the Velodyne suite of products, especially the M1600 sensor, is ideally suited for your automation and robotics needs. VDK provides even more value, making it easier to integrate the sensors. With regular releases, VDK will evolve, provide new features and enhancements, as well as improve over time. Please stay tuned as we have more innovations on the sensor side and software. Thank you very much for taking the time to talk to us today. And I think now we can move into the Q&A section. One thing, Mary, if you can help me out, we have a bunch of questions coming on the Q&A, so please keep them coming. One thing that I think I neglected was I probably went too fast over the spec section. Can you go back to the sensor with the spec table on the right? I think that was something that come up a couple of different times, if you can. Yes, thank you. So why don't we start off on the hardware side? We actually have a couple of people here to help answer some questions. So Klaus, who's on our product team, there was a couple of questions regarding the field of view and also the size of the sensor. Maybe you can help us with that.
Yeah, so one of the questions that came in is asking about the vertical and horizontal resolution about this from the sensor. So our horizontal resolution is 0.2 degrees. And then the vertical resolution is coupled to the frame rate. So at 10 Hertz, the vertical resolution is 0.2 degrees. At 20 Hertz, the vertical resolution is 0.4 degrees. And at 25 Hertz, the vertical resolution is 0.5 degrees.
And size, Klaus?
The size of the sensor is 180 millimeters by 81 by 55, and it weighs around 900 grams.
Excellent. Thank you. So for some of the next questions, maybe it'll be on the software side. So I think there was a question about the AGX and its compatibility with functional safety. Maybe Chris or Sherwin, you can help us with that.
So the package AGX, to my knowledge, is not the industrial version, but we can, we're certainly welcome to talk about options, and please, feel free to email. We can discuss further on that. Thank you.
Great. So there's a couple of questions that I see really have to come down to how hard is it to get VDK up and running, and actually what kind of support can I expect from Velodyne to get it up and running, and how often do these updates come? Maybe Chris, can you help us out with that?
Sure. So the updates are quarterly. So once a quarter, we'll have an update for y'all and make sure that everybody's aware of those things so that you can look for those. As far as getting it up and running, it really is straightforward as far as getting it out of the box and turning on the machine. We provide you a quick start guide so you can plug things in and get things going. And we're of course available. There's an email that you can use to contact us, and we have lots of folks available to get your questions answered as quickly as we can. If you do have any issues with kind of setting it up and getting things going, we are available to support that. Did I cover everything there, Sherwin? I think it was.
Yes, I think so. I think for that one.
Okay.
Klaus, maybe we can go back to the sensor side. I forgot to mention the power consumption. It is low power consumption. Maybe from a specs perspective, what are we talking about?
11 watts is the typical power consumption. It can peak up to 15 watts, but 11 watts is usually under typical conditions.
Great, thank you.
Sherwin, there was a question about how do I get a VDK? Please contact our sales, our sales team, and we can set you up with the right people to get a VDK in your hands.
Okay. And actually, there was a question on the chat about the not only the support for VDK but for the sensors themselves. So when you contact Velodyne, we have the capability to help you understand which sensor works for you, and we have simulation software and all those kind of tools to help you understand what hardware, in addition to the software, needs for you. So please contact us. We're more than willing to help you. Let us know what your needs are. Back to a hardware question. So temperature range, Klaus, what's the temperature range for M1600?
Yeah, so the M1600 is from -10 degrees to +60 degrees at the moment.
Yeah, got it. Thank you. And another question on the sensor side, dual return mode. What does it actually mean?
Dual return mode means that it can be configured to get first and strongest point cloud points first or strongest last. And we have it's configurable, and we have the option of single mode or dual return, and it's already available now in the M1600.
Excellent. Software question, Chris. Is VDK can be used to post-process in addition to real-time?
Yes, that's something I neglected to mention in our preview. It has an offline mode. So if you have previously collected the data, you just run in an offline mode, and you can, as algorithms and systems developers, we all know the value of being able to do things with canned data. So we built that in, so you can certainly take data you've collected previously and run it over and over again as many times as you need to while you're developing and figuring out your solution.
Excellent. Actually, if we kind of stay on the software side, there's the question about multiple sensors. How do you deal with multiple sensors, and can VDK deal with those?
So VDK does not currently support multiple sensors. There's a possibility of that in the future, but currently it's a single sensor environment. But please feel free to contact us, and we can talk. And we are sensitive to our customers and what they're looking for. So please let us know, and we'll discuss that with you.
Thank you.
Oh, and I should say that you can contact me. There's information coming at the end of the show. So you can contact me directly. We'll get you answers.
Sensor question, wavelength. Klaus, what wavelength does the M1600 work at?
It's working on 905 nanometers.
Okay. And then also related to the field of view question, I think there was something about the field of view and the pattern with the sensor. Maybe we could talk a little bit about that.
Yeah, so if there are specific questions about the pattern, it would be great if you can contact us. We can provide a scanning pattern diagram, but the scan pattern is uniform in most of the field of view, and it changes at the end. So definitely something to talk based on use case applications.
I think there's also a couple of questions here regarding the durability and survivability in dirt and rain and other conditions. Maybe we can talk a little bit about that, Klaus.
Yeah, so the sensor is designed to withstand harsh environmental conditions. It is IP67 rated, which means it can be immersed up to 1 meter of water, and it also resists dust ingression.
Great, thank you. I think maybe we're getting close to the end here. Maybe one more question here. Sorry, let me take a look. Is there any sensitivity to the object colors in paint? Is that something that we can comment on or have a comment on?
From my perspective, I mean, that's a great question, and this is something that affects most lidars, and there's some colors that are subjected to the performance of the lidar, black being one of them.
And just to build a little bit on that question, I think that's a perfect question to ask, and it's a great opportunity for us to interact and collaborate with you. So we actually have a bunch of solutions on the sensor and software side, and simulation software that we can work with the customers to answer those type of questions. So it's one of those things that we can really show you once you engage with us on the sensor and on the software, help you find a solution for whatever situation that you're looking for. So it's actually a good example of how working together we can solve the problem. I think we're pretty close to the end there, Pam. Maybe you can chime in.
Awesome. Thank you so much, guys. We are coming up on time now. And if we didn't get to your question, that's not a problem, because you have contact information for Sherwin and Chris right there on your screens. So you can reach out to them directly with questions about our Velarray M1600 or our VDK software solution. To learn more, you can also visit us online at velodynelidar.com or on our Velodyne social channels, including Twitter and LinkedIn. Again, as always, this webinar recording will be available to view on Velodyne Lidar's YouTube channel. Thank you again, Chris and Sherwin and Klaus, for spending your mornings with us. And I also want to thank our audience for watching today. If you're interested in learning more about the latest developments in the mobility industry, be sure to join us on April 15th for our next episode. We'll be featuring Asad Lassane, co-founder and CEO at Blue City. And Asad will take us on a technical deep dive into our intelligent infrastructure solution, also known as IIS. And if you're not familiar with IIS, it is already deployed across 3 continents And just a few weeks ago, it won the Innovation Award at South by Southwest. So our next episode is going to look specifically at the immediate benefits IIS can provide for city teams who are focused on traffic operations and Vision Zero. So we hope to see you next time. Thank you.